the last and final video for this week's lab section. How to make your last task. You're going to model a basket and then add wheels and kind of make it like an automated basket. As you might have already guessed, this involves significant amount of assembly modeling. So I'm going to show you a few ways to make the basket and the handle, which can also be replicated for the axle and the wheel, and then attach it to the sorry, to the base of the basket. Now, without much delay, let's get started. I already have a rough non-dimension baskets. As you can see, the handles don't really meet each other because they weren't really dimensioned properly. But before I get into those details, let's first see, how do I make the wireframe aspect of the basket? How do I make a basket such as this? So let me slow it down and let me switch on all the reference planes and sketches so that they're all visible for you. Let's go back to the timeline and see. Give me a second. Yeah. So extrude a box, give it a taper angle, draw, give it fillet, and draw the outer curvature, make pipes out of it, and hide the base body for you to have the structure. Let's look at it a little slowly, one at a time. What I have, I made a basic structure and then I extruded it. I use the shell command to create the hollow basket shape. Now I have the basic shape of a basket, but this is not a wireframe model. So I go ahead and add some fillet, and then I take a reference plane. I create a reference plane along this one. If you want to see that, what construction is which on the plane. I create this plane in the right in the mid plane of this and this plane, this slanted plane over here, and then I draw a U-shaped, or rather a V-shaped line. Now this, as you can see, is very similar to the outside portion. And if I go ahead and give it a pipe command, I already have, I'm going to hide reference. I already have one single unit of what makes the multiple of these wireframes. Go ahead and pattern it linearly. Take the top sketch, make a pipe out of it, and make components out of them. Well, the step is not really necessary except for an assembly modeling. And then combine the objects. Now, you will notice that over here, the components are not completely joined. So I would create a T-spline on these joints and use something called as the weld vertices. So you can use weld vertices, and you can create a T-spline over here and weld them together. Alternatively, you can also use something called as the web command. Instead of creating pipes, you can draw a sketch. Now, how web command works, I had in the previous videos asked you to look into web and rip commands. If you haven't, please go ahead and try to make them. You create an open sketch and you create a thin feature, and then you kind of extrude it out to give you a surface like this, kind of like the ribs you see in your extrusion molded plastics in your dustbins, water bottles, etc. So that is another way to do it. In this drawing, I'm not doing any of those things. Instead, what I'm trying to do over here is create this handle, which is of more prominent importance to me. So for that, if you see, I'm going to go back in the timeline, extrude it out, I shelled it, I added a construction plane. I'll show you all the construction plane for ease of access. Right, I added a construction plane and I took these two lines and made them reference lines. And then I drew out the notch which will hold the handle with respect to this line. Then I mirrored it about this mid plane. And using a pipe command, I generated a pipe from this very shape, the U shape that we saw before, converted them all to components, drew it out, and it comes off over here. I created one half of it, then I assemble this with this, then I mirror it about this. Now, it seems very easy when I show it on a timeline, and it is easy when we're going to go ahead and make it. So if you want, here's a step-by-step tutorial. To make things way more easier, let us just take one of the side views. Say I take the right side and sketch on this. This is how a basket would look from the side. Just gonna make them equal. Dimension. Let's see. I want to make this 100. So this say 75, and distance between them so 150. This is a fully constrained sketch, finished sketch, extruded. I'm going to extrude it for about 75. Well, it's a box. I might go ahead and extrude it a bit more, or maybe not. So I have a shape here. Alternatively, you can also, there's just another way of creating the basket shape. The easier alternative would be finish the sketch, extrude it out, choose the profile, sound extrude for like 80 mm, and give the minus 15 tapering angle. There. Easier. The only problem being you might have to calculate, if you're going to go with dimensions, you might have to calculate what 15-degree taper actually means, whereas in the previous case, in the previous sketch method, you don't have, you just have to give the heights and the gap between the non-parallel and parallel lines, a trapezoid, and you're done. Next, let's go and use the shell command. Sorry. Is it your 2 mm thickness? Sure. Now I have a kind of basket looking shape, but because the dimensions aren't great, I don't really like the shape much. Yeah. Right. Now I'm going to create a sketch on the surface. Let us take this. There's another interesting command. When you look for create, there's something called as a project, by the short form. What it does is if you have this line as a part of another 3D model, you can now have it as a part of your sketch. Why am I doing that? Because I need to make a line and create an arc. Mirror line. click on it. It's somewhat bigger than I want, so I'm gonna fix the dimensions. 5 and 5. 3 and 3, much better. Then now create an arc. 3-point arc, see? Three-point arc. As you saw, a center point arc might have given you something as you picked one of these as a center and you drew it from there. I wanted a 3-point arc. That is done. I'm going to go ahead and create a circle. Remember the dimension of the circle. I'm making a 3 mm diameter. Remember the diameter of the circle. You will know why I want you to remember the dimension of the diameter. There's sketch. Now once this is done, I'm going to go ahead and extrude this body. Not much, just about 0.75 mm. Okay. Now that that is done, let's mirror it about the other side. Easiest way to do is take midplane. Choose the planes between which you want it to be a midplane. Okay. And now mirror command. Now because the bodies are merged, let's take the feature command, features instead of body this time. Select the mirror plane, and there we have ourselves two of these shapes. Now there's something else I wanted to do in this extrusion is because these are, as opposed to what I had envisioned, I drew them the other way around. If you see in this drawing, you will realize that these notches were on the top side, whereas in this they've been flipped. So instead of correcting that, I'm just going to go back to extrude and just going to do the two-sided extrude. Or you could sketch out from here and draw it out. Now, the more important part is to create the pipe. So I will look over here. I know take the dimension of the width of the basket into account when you draw the handles for the pipe. You don't want them to intersect like this. You want them to join neatly. So the easier way to do that would be let me try to take a plane. Let's see. Let's come back to solid. Let's try to construct a plane. I'm going to construct. Let me see if I can construct a plane between these two features. It shouldn't be a huge deal. Plane tangent the face at a point. Not what I want. Let's just draw it directly on this plane. Take this plane, sketch, take this line, and this line. Project them. Project the lines, not the faces. Okay, now initial sketch. Sorry, that would probably not work. Take a line. What I'm doing here, if you notice, make it a construction. Now you get that point to draw. One thing that I don't really like with Fusion 360 is how inconvenient its control panel can be, unlike something like SolidWorks or CATIA, which is kind of more reasonable to use the control interfaces with. But oh well, this is open source, so it's fine. These are not dimensioned again, so you might see a bit of an overlap, but this will serve the purpose. Finish sketch. Right. Now go ahead, take the pipe command again. There you have it. Your pipe is now ready. Now I have two bodies. So my body 1, I'm going to make it a component. Body 2, I'm going to make make it a component. Now I'm going to take the joint, take this, and snap it in place. With this. Now this is a ball rotation. However, if you make it a revolute, you will notice you make it a revolute joint. Let's try rigid joint. It won't move at all. A revolute one would move across. You can set limitations to your revolution by giving it an angle. Yeah. So now when you say revolute, it moves completely, but stops instead of completing the full 180-degree twist that's supposed to complete if it starts from a point. Alright, so that was adding the constraints. Great, now one part of it is done. I'm going to go ahead and don't really need this to constraint. Now take this face, construct a plane on this face at no offset distance. I think you know where this is going. Mirror it, mirror this body about this mirror plane. There you have it. Now you can see that if I try to make a joint over here, this would probably not make a joint over here like this, because these two are not equally divided. If you wanted them to be equally divided, take this measurement, take this length to be half of the length of your base. But since this was not measured out properly, we had something like this. Now when you make the axles and shaft, go to the bottom. For you to make shafts, you will not the bottom view, sorry, take a side view. You will have to add a shaft over here, and then you'll have to add a shaft on the other end. So you will have two cylindrical rods underneath this. You can either draw a circle and extrude it, or draw it separately and join it using the joint feature, and then add wheels to it. Wheels will be rotating, so those are revolute joints. Your shaft will be fixed rigidly to the body. So that was about some tricks to use with respect to your project. This is not the only way to do it. What I'm giving you is how to use the tools that we have done previously, how to use all of them and put them together in the most abstract way possible. What I want you to do is use these tutorials as a basis to build your own drawing, to kind of sit with the problem, struggle a bit with the interface, go around messing a bit with the interface to figure out the answers to the final problem. And the reason why I'm asking you to do this is while I can give you an exact copy of the model that you have to make and you can just follow the steps reading the video, that will not develop your skills as a designer. However, struggling a bit with the software, taking abstract concepts and building on them will definitely improve your thought process as a designer. And regardless of whether you use Fusion 360 or CATIA or any other modeling software, you're going to have the basic intuition towards designing. And you're going to have fun modeling, which is all this class is all about. So good luck, have fun. See you.